Hello, this is Reach Sub-Orbitals flight test of their single stage to suborbit vehicle, Aspiration. In this simulation, we'll be attempting to reach 100 kilometers with a Merlin 1D engine. The runtime should be 8 minutes. This is being simulated in Simulink, but visualized in flight gear. We will have readouts of Mach, altitude, fuel mass, as well as alpha. We'll also have magnitude of acceleration. Which I will read up first. We'll start at about 50% throttled and increase. And as we are accelerating, I will be decreasing to keep us under about 30 meters per second squared. Without any further ado, let me start. There may be some lag due to running the simulation in Simulink while trying to record the video. I need to make sure I don't hit straight vertical, which will cause a singularity due to theta at 90 degrees. Now as we start accelerating, I'm going to throttle back to maintain at about 30. Let's see, our fuel mass is over half expanded. As we're reaching up 30,000 meters, 30 kilometers. Above 40, we're going to start losing where we've lost thrust. The fuel is burned out. We are now coasting and decelerating due to gravity and some aero forces. Above 40,000, we start losing control effector. Above 60,000, we have almost no control effector ability. Here's our Mach data. Reached about Mach 3.5. We're approaching 85,000 meters. Sorry for the cough. Approaching 100 kilometers. Right now our rotation is coming from our pitch down rate that we had as we were losing control effector ability. So we will continue to pitch down until we start re-entering the atmosphere at about 80 kilometers, where we'll see So we're right now hitting about 100. We're going to peak out at about 110 kilometers. When we hit 80, we'll see gravity start to pitch us down nose first. When we hit 60, control effector ability will start coming back, and at 40, we'll hit the bulk of the atmosphere, and we will have a rapid deceleration, and we'll complete the pull-up. Unfortunately, flight gear does not do a very good job rendering the environment above about 40,000, hence the quality will look. So now we're hitting coming up on about 80,000, and we're hitting the atmosphere, which is causing us to have that hard nose down moment. Now that we're re-entering, I'm going to start pitching up to arrest the nose down moment to keep us at about a 10-degree alpha through the pull out, 10 to 15-degree alpha. As we are hitting 60, density is picking up, and I'm regaining much more control. You see our Mach is, again, going to hit about 4.5, I think. And now we're hitting about 40,000. We're going to have a rapid deceleration. The control effector should be back. And I'm going to be completing the pull out. It's going to get a little glitchy as the time step in simulation a little troublesome at times. Depending on when I really start the pull out, we can stabilize anywhere from 20 kilometers down to about 10 kilometers. Right now I'm climbing back up to help kill the speed as we are coasting. The simulation does not have any ground interaction, as Simulink cannot discern the visualized ground level of flight gear, so there is no landing simulation, so we will just coast until the simulation time expires, which is 8 minutes. We are approaching Mach 1. Again, this has been a flight test of Reach Sub-Orbital's suborbital space vehicle for space tourism, the Aspiration. Appreciate you watching, and hopefully in future iterations we'll have more improvements like RCS thruster control and perhaps landing gear modeling. And there we go. We reached 8 minutes. Simulation is stopped. Again, I appreciate your time. This has all been simulated here in Simulink. and visualized in flight gear. Have a good day.